about both Mayas. Don't worry. We said Maya once because there's too much. You guys are both Maya.
Yeah. Okay. This is going to be... Speed.
Run.
Okay, not too fast. Not too fast. Okay, I am going to give you guys some rulers. Those of you watching from home. Okay, we're going to use a ruler. We want to draw the perpendicular bisector to BC. Okay, we should recognize both of these words. Perpendicular. Okay. Perpendicular means what?
Oh, they don't touch each other.
Perpendicular means
they form right
490 degrees angle.
Okay, guys. Just say 3.
Okay, perpendicular means it has to make a right angle. And if it's a bisector, it has to go through the midpoint. So
it goes through or just like go to the midpoint and go out?
It doesn't matter. I mean, listen, what I want you to do, we want to draw the perpendicular bisector to BC. So take this side.
Like this would have been so helpful.
Measure it.
You want to approximate. You don't have to actually measure. I mean, I gave you the ruler, but if you want to just approximate.
2.75.
Okay, so let's say right there.
5.5. 2.75.
Okay, let's say that is the midpoint. But in order to say that we know for sure it's the midpoint, I want you to mark the two sides.
Are you sending it the 0 line?
Now, I want to make a segment or a line or something. I want to make sure it goes perpendicular. So if you hold the ruler, it's going to go kind of like this. Do you see that? You want to make a right angle here. Can you do that? Okay, you want to make a right angle that goes through. So kind of like this.
Oh, I think I have your you do that.
See, how did I get this? I feel that exactly what's in the middle.
It does not have to go through a vertex, okay? Has to go through, so there's two things I need marked. I need the two segments marked congruent, and I need the little box. Okay. All right, so here's perpendicular bisector theorem. If you have a point on the perpendicular bisector, okay, so if you have a point on that segment, it's going to be equidistant from the endpoint. So if we take our ruler and we draw a segment from C to B, or from C to A, so if there's a point on the perpendicular bisector, if we connect the segments to the endpoints, they have to be congruent to each other. Basically, what this ends up making is an isosceles triangle. Okay, so CD is the perpendicular bisector, then AC is congruent to BC. Okay, so here we have a picture. RS or SR is the perpendicular bisector. So if SR is the perpendicular bisector, then these two segments have to be congruent. So we have 2x plus 3 equals 4x minus 10. So we get,
This was a yucky number.
we'll just write 13 over 2 is x. We want to solve for x, and then we also want to find RT. So RT is going to be 4 times 13 over 2 minus 10. All right, well, 2 goes into 4 2 times. So 2 times 13. 26. 26 minus 10.
16.
Okay, next page.
That was easy.
Oh.
Good? Okay, converse. This just says, if you know a point is equidistant, then it is on the perpendicular bisector. So in other words, if these two, if AC and BC are congruent, then you know CD is a perpendicular bisector. we're going to do 4 different segments today. So basically what they're saying is if
Oh, just like it's just a segment bisector, but it segments.
it's basically like if you have an isosceles triangle, then that means the line that goes right through it would be the perpendicular bisector. Okay. All right, angle bisector. Some of these words should look familiar. Angle bisector, we should already know. Yeah, we know this. The only difference is we want to look at specifically within a triangle. Okay? So this divides the vertex into 2 congruent angles. So we want to draw the angle bisector for angle B. So
Do I have to draw the line all the way down to the bottom?
it doesn't matter. I'll just draw like a ray here. It can just be a segment if you want. Well, a bisector cuts it in half. A bisector could be of an angle or a side. A midpoint is just for a side. Like there is no such thing as a midpoint of an angle.
Bisector is like a line of midpoint.
The midpoint of an angle is.
So why do you ever need to use the midpoint? Why is it not always bisector? Sometimes. Okay, just.
Yeah. Okay. If AD is an angle bisector, we want to find measure of angle ADC. Okay, so if this is an angle bisector, that makes the 2 angles at the top congruent to each other. We know this is 66 and this is 50.
Oh, so they have to combine.
So all 3. So if I did 180 minus 66 minus 50 and divided it by 2, we get something.
You get something.
Let's see. Somebody has a calculator.
64.
64.
64.
I think it's 64. Wait, no, it's 32.
Well, 64, and then we want to divide that by 2. So this is 32, and this is 32.
98.
Okay, now that we know each of these, well, there's 2 ways we could do it. Angle ADC is an exterior angle to these 2, so we could just add those. Or you could look at this triangle, all has to add up to 180.
82 and 98.
98.
What? Oh, that like equals 64.
Yeah, you could either do
How did you know
these 2
64?
add up to this one, or you could do 32 and 50 add up to 82.
Oh.
So how much?
You got it. I don't get it. Sure.
Okay, well, yes, you do. You just need to maybe think about it. Okay, angle bisector theorem. If you have an angle bisector, so if these 2 angles are congruent, okay, this point is equidistant from the sides. That means BC is congruent to CD. Okay. So a point on an angle bisector has to be equidistant from the sides. And there's a reason we draw perpendicular. Like if you talk about the distance, I don't want to draw the distance like sideways. I want to draw it perpendicular to each of the sides. Good, no? Like if I draw on the board,
No, let her explain it, guys.
like if I have a point and a line, would I draw the distance like
Sammy
this?
understands.
No.
No, I would draw it so that the distance is perpendicular.
Okay.
All right.
Get it.
So what do we know about x? What do we know about 2x and 2x plus 6 and 4x minus 1? They're equal to each other. So 2x equals 7. Good. And then I also want to find EF. EF is 4.
How do you know it's 4?
Times 7 halves minus 1. Sorry, I paused. Okay, same thing. There's a reason I leave it as 7 halves. Right? 2 goes into 4 2 times. So 2 times 7. 14 minus 1. Okay. Good?
That's my tooth.
It's
Wait,
four-
that's Jason. Will you be able to
14.
see when you spin the wheel?
Wait, it's 14 minus
Oh.
1, so it's 13.
Later. Okay, the converse says if these two are congruent to each other, then angle ABC has to be congruent to angle CAD. So just the opposite. So if they're equidistant, then this has to be an angle bisector.
Wait, can you go up?
Oh, sure.
Okay, got it.
Good. Okay. So we want to determine whether there is enough information to find the value of x.
Okay, A, yes.
Well, we're going to do 5.2 because
I don't know about B.
A, yes.
A is yes.
Wait, B's a little
X equals
And
one.
then, wait, but B, like, we know it's 9.
So if these two are congruent, could we figure out what x is? Yeah, x and 20 would have to be the same.
Oh, we actually.
Okay. I see a perpendicular. This looks like a perpendicular bisector, but
It's height length thing.
do we
don't have
know?
anything.
Height length.
We
We
don't-
don't know the base. Height length.
We don't know the base. We don't know.
What?
Hypotenuse leg. HL.
I know, but we don't know if they're congruent. We don't know if these are congruent.
Yeah, but you have the other leg.
Reflexive.
You know the triangles are congruent.
No, but I need a hypotenuse.
Oh, you don't
but
know the hypotenuse.
That's what the whole point. I need to know what the hypotenuse would be.
7.
We would hope it's 7, but we would need to know in order to have. I would need to know
How do
that
you know
these
one?
two are congruent.
Okay.
Oh, because you know X is.
Couldn't it also be the middle one? I don't know.
Yeah, but we need 2 sides. We would still need 2 sides. Okay, so we did perpendicular bisector. We did angle bisector. Next, we want to look at a median. So this is a new one. This is a segment that connects the vertex to the midpoint of the opposite side. Okay. So we want to draw the median from B to AC. So the first thing we want to do is figure out where would the midpoint be
In the
on
middle of
AC. Okay, so let's label that first.
Can I just guess?
Yeah, that's fine. I'll just put a point here. You can just eyeball it. It doesn't have to be
Do I have to do
perfect.
like the 2 lines?
Put the 2 lines because we want to make sure that we know that that's a midpoint.
You draw the straight line down.
Now you take the ruler, but this time you have. Remember the perpendicular bisector didn't go through the vertex? It just kind of like went through the triangle. This one has to start from the vertex. So we're going to start from B.
Did I have to hit both angles? I have both lines. Both lines.
What do you mean by both lines?
line.
Gotta pass through the vertex. Has to pass the midpoint.
But I thought this is when you're supposed to draw the right. That one.
The right,
I thought
that
this is when
one.
you're supposed to draw that angle.
I don't think he
I know what
understands
you
this.
said. I don't get it.
That drawing right there, I thought we were supposed to draw it like that. I thought we were supposed to draw straight down.
Oh, that's an altitude. Okay, median. There's no right angle with a median. Okay, the median goes from a vertex to the midpoint of the opposite
Can
side.
it be a right angle or no?
Yeah, if it's a equilateral triangle or an isosceles triangle.
The scalar.
Okay, find the value of x if AD is a median. So if it's a median, that just tells us these two are equal to each other. So,
Oh yeah.
You finally understand?
you all right, Sammy? Okay. All right.
What?
His brain is working, or it is? It's not working. Okay. So we get 15, 3x, and it didn't ask for anything else. So if you know that it's a median, you just need to set the 2 parts equal to each other. Okay, last segment. So there's 4 total. Altitude. Altitude, we think of height. So the altitude you should know. It connects the vertex, and this is going to be perpendicular to the opposite side.
What?
Okay.
No, this is what I.
Okay,
this
so
is that
listen,
drawing.
when
It's
you
that
do-
drawing right there.
What's that drawing?
When you do the area of a triangle, remember when we did area of a triangle like way back when, you would always have to make sure the height and the base are always perpendicular to each other. So if I want to draw the altitude, so
do the thing out and the thing in.
okay, so I want to draw it from C to AB. Okay. So if my ruler's not here.
Oh, this is
I'll
the
make it a little
bonus?
smaller.
This is the bonus thing.
Okay, I want to make a right angle. So start from
Why are we
C.
doing that? Why would you do that? See, oh,
It's because the directions say so.
Oh, just go straight to the middle.
So it's not going to be in the middle. Okay,
Straight.
Jonah. It's going to be over here more. Do you see how, like, I want to try to line up my ruler? Like, I wouldn't.
It has to be a right angle.
I want to make it a, so, like, right here. Does that look good?
oh, I see.
All right, let's do that. So I'm going to draw it this way. Sorry if you're. Oh, let me.
Oh my God, that was such a nice
This looks good enough.
Okay.
Do they both have to be right angles?
Put a right angle in the where it intersects. Mine's a little crooked, but
Aren't these both right angles?
that's yep. Okay, now I want to draw from C to AB. Okay, I have a problem here. If I try to go from C to AB,
It's not gonna be perpendicular.
okay, so when we have an obtuse triangle, I'm gonna need to extend the sides. So I'm gonna take my ruler, take AB, and I just want to make it longer.
Yeah.
Now, you can extend it on both sides. You can extend it on one side. I'm just going to extend the whole thing. Now, what we want to try to do is this. So now, Sammy, this is what we're going to try to do.
Did I do it?
Okay.
Or
We've been doing
Okay, but no, it's not the same. This is the one that makes a right angle. So I want you to ignore these two lines. If you were to draw from C to this line, and I want to make it a right angle.
Oh, I did it
I'm
right.
gonna go like here.
I did it.
You see that?
You know how the kids glaze us? You know, why is he weird? Okay.
Look at like the pattern our phones are in.
You want to know why though?
Oh.
You wanna
So
know why?
cute.
Good?
Yeah, I told
Yeah.
you in the
All right. So find x and ij if hk is an altitude. So an altitude does not go through the midpoint. These are not.
X plus 3 equals 90.
Good. So all we know is that this has to be a right angle. So 3x plus 3 equals 90. So 3 equals 87.
What's that?
87 divided by 3.
It's 29.
I haven't even
Okay.
tried.
Now, ij, we also want to find. Okay, well, if x is 29, this part is going to be 29 plus 8, which is 37.
If all you
27
know is
minus 9.
H, K,
18.
if you're how do you know which angle to draw the line from? Like, how do you know to go from H instead of I? If you're making the altitude.
57.
Am I? Oh,
57.
Okay, wait, say that again.
Let's say you're making that, like, you're right
Oh.
from the altitude line.
There's
Does it
going to
tell
be
you?
3 different altitudes. I will always tell you what vertex to start from. Okay? So in this case, the altitude starts at H. But if I told you to start at I, I would go straight up and down this way.
That be the median?
Okay, yeah, median means that B is the midpoint. So x squared
Oh no.
plus 5 minus 9 has to be equal to 2x squared minus x.
What?
I don't want to factor it.
I don't like factoring.
Okay, it's a median.
What
Okay.
do you want above? That's 29. That's fine.
Wait, how does it mean?
Median means it goes to the midpoint.
So it's x squared minus 6x plus 9 equals 0.
It's x minus 3, x minus 3.
Good.
So it's 3.
So x minus 3 times x minus 3. So it's just going to be x equals 3. Now I want to find the length of CD. Now, it shouldn't matter which one we plug into. We should get the same answer. So let's just see. 3 squared, so that'll be 9.
9
Plus 15.
plus 15.
Plus 15 minus 9.
It's 15.
So 15.
15 times 2, so it's 30.
So
You
CD.
did not have to solve the other side. You knew they were going to do it.
I would say if you have time, I would probably make sure, because
Just needs to go the wrong end.
if you had time on a quiz, I would plug it into both to make sure they come out to the same. So if I plug in 3 here, that would be what?
9.
9 times 2.
9 times 2 is 18 minus
15,
3.
15.
So it works.
Okay, last one.
You learned actually.
Okay, we want to find GFH. GFH is up here at the top.
2x squared.
If H, or sorry, FH is an altitude.
Oh, this is smart.
So if this is an altitude, that's a right angle.
And the right angle and the other one have to be I don't know what I just said.
Okay, these
linear pair.
Oh,
These
because
make a
they're
linear pair.
53.
Supplementary.
They're
53.
corresponding.
Wait,
Right?
the
Corresponding.
question mark is 27.
Wait, are we sure?
That's what I was gonna say, but no,
it's
no.
not.
The question mark is
Not parallel
27.
The question mark
Let's
53
see.
is plus 90 is no.
It's 27.
Wait,
No,
wait,
you're
wait.
right. The question mark is 27.
It's 37.
Okay, that's a 10-degree difference. Is it 27 or is it
It's
37?
37.
No, it seems.
53 plus 90 plus 37.
Sammy, I wasn't gonna say it. I was gonna let you come up to the conclusion that.
Oh, it's not 37. Sorry.
It is 30.
Because it's just in a simple math.
Is it 37 or 27?
Watch it be like 47. It's 47.
It's
47?
It's not 47.
It's 37.
At least we can agree.
Wait, it's 50 plus